Hi everybody, this is Stephen Pugh. Want to go through another video with you. We're still looking at saws in various types and various situations. This is video number 12 and it's part of the setup and operate a circular saw video. However, there's other saws been mentioned. One of them isn't circular at all, it's actually the Jigsaw. We're going to talk about the Jigsaw next. Now the Jigsaw is a great tool, I have to say. We all roughly know what a jigsaw looks like, but it has a very small straight blade. Most of the time the teeth are all facing upwards, so that as you're cutting it's pulling the wood upwards to meet you. But you can actually have blades where the teeth are facing downwards, so as you're cutting, instead of pulling up and splintering the wood to the top, it actually pushes the wood downwards. They're a little bit harder to use. They tend to jump about unless you're very careful about it. Changing blades is a very simple thing, really. It's something that you'd need to look at the manufacturer's instructions. We need, as guys, we really need to get used to reading the manufacturer's instructions. They're the people who made the thing, and they're the people who know how to work it best. So when you get a new tool, or somebody gives you a tool to use, always ask for the manufacturer's instructions and take a minute to read what they say. One of the things that's important with using jigsaws is that the blades sometimes can be quite thin. They can get very hot. So you just need to be very careful that we don't overuse the blade and push too hard and expect too much of it. If that's the case, it will just get hot. And when it's hot, guess what? It will then become supple and it'll start to bend and you'll get curved cuts and all the rest of it. The other thing that's very important, there's two adjustments on a jigsaw in the main. The first adjustment will be the speed, okay, how fast you want it to go. And may I say that generally speaking, you want that speed to be quite high. You want that wood that's in the way to be got out of the way as quickly as possible. Now, the only way to do that is to have the speed fairly high so that it actually is ejecting the wood and clearing it out of the way. That's one of the great mistakes, is to put it on a slow speed and then you find that the blade gets very hot. The other thing is it has what's called a plunge effect as well. So the jigsaw doesn't just go up and down. It also goes up and down in a circular motion like that. And you can adjust that effect. You can adjust it so it's vertical. You can adjust it so it does it a little bit, or you can adjust it so that it does it a lot. Okay, and of course it depends on yourself and your experience as to quite what setting you want it to be. It's called sometimes the pendulum setting. Okay, and that's another important feature of using a jigsaw. Now there's lots of different types of jigsaw. There's probably as many types of jigsaw blade as you've got people in the world. I've got no idea how many there are, but there's thousands and thousands of them. In the main, there are a few types. In the main, you've got the multi-purpose blade. Okay, that's the one that you just want to have in your kit, isn't it? So it'll cut timber, but it'll also cut board materials as well. Now, they're all fairly aggressive teeth, if I might say so. Fairly aggressive teeth. You just need to be very careful that you don't let it run away with itself and start being aggressive with you. The next one is the multi-purpose blade, which will cut timber and it will cut plastic. Now, plastic's an incredibly hard substance mainly, and so it's quite tricky to cut. You need to make sure when you're cutting with plastic that you have at least 3 teeth in contact with the item being cut at any one time. That may mean that you go for a much finer blade. If that's what's necessary, then that's what you do. We also have another blade which has a negative cut to it. We talked about that in the previous video. And this is for cutting very thin steel. You don't want, when you're cutting thin steel, to have a blade that's too aggressive. So instead of the hook being positive, the hook is negative, and that allows it to not grab hold of the steel. And then, of course, you have another one which has very fine blade. It also has a negative hook. And that's for cutting aluminium. Aluminium is a very soft substance most of the time, and as it's cutting, so it gets very hot and gets very hot quickly, but the saw doesn't manage to eject the cuttings very quickly. It doesn't eject them very often fast enough, so it tends to clog up. That's the point. So really, that's just a few of them. That's just a few. And I mentioned before, didn't I, that you can get what's called a down cutting blade. What do I say about jigsaws in their use? Probably the most important thing I say about them is secure, secure, secure. You must secure the wood. You must secure it enough so that it doesn't vibrate, and you don't want to have to move it halfway through while the thing's on. So it has to be really secured, much more secure than anyone normally imagines. Most people imagine that a jigsaw is a lovely little fluffy thing that's never going to harm anybody. Well, let me tell you something. It's got a powerful motor and a very sharp blade. This is not a fluffy thing. This is not something for the light-hearted. What you need to do is have your head in gear, and you need to make sure that you're safe, and then even more safe. Keep it secure. Now let's have a look at power drills. Now power drills come in lots of different varieties. I mean, you can have the really large drills, the SDS drills. Very often they have a trigger that's able to be pulled at various stages to make it go faster or slower, so you don't have to stop and adjust the speed. You automatically can adjust it by just releasing your finger a little bit. They're normally quite big, okay, and they normally have a hammer action. So as well as turning, they will also hit their way through the wall at the same time. So they're not just turning to clear the debris, they're actually hitting the wall to break the concrete or to break the brick. That's what's called an SDS. Now SDS chucks are special. They don't have a normal chuck on them like you would expect on a drill. They have a chuck whereby the fitting that's put into it has got special grooves in it, and it clicks and just clicks in place, and it, funnily enough, it looks loose, but actually it's held fairly well. Now, there's another type of drill, which is a pillar drill. This is the sort of drill that's mounted on a post or mounted on a bench. And you literally put your wood under it and you spin the wheel. As you spin the wheel, so the drill comes down and then comes back up again. A pillar drill is exceptionally handy when you're doing a lot of repeated work. It enables you to get very vertical holes and very accurate holes. And if you're having to do a lot of repetitive work, you can literally just go down, 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 and it's much more controlled than you would have if you did it entirely by hand. Another thing that's very important nowadays is battery drills. And the great thing about battery drills is that they're now getting better and better and better. And we're now getting to a situation in which you can charge a drill in just under half an hour, maybe 3/4 of an hour, and it'll take it from nothing all the way up to full. And when it gets to full, it will then last for a couple of days. That's incredible, really. That's the technology that we're thinking about today. Normally, these type of drills, they have a speed selector, so you can go fast and slow. Most of the time, I have to say that I nearly always put it on fast, and I've got used to fastness. The trigger is normally an electronic trigger, so as you squeeze it, so you get more power, and if you let go, you get a little bit less. And you can learn to control the speed simply by the control of your finger. They also have torque setting, so that if you want to set it up for putting screws in consistently and you want them to go to the same depth, you can adjust the torque so that as you drill the screw in, it will stop it. It'll stop the machine at just the right setting, and you just keep going in, and they all go into the same level. So using the torque setting is an exceptionally good thing. The other thing about it is that sometimes you can have separate batteries. So for example, if something runs out, you don't have to stop work. What you do is you pop the battery out, put it onto charge, and take the one that was on charge and put it back in and carry on. So whenever you're buying a tool, for example, if you're going to buy, just remember that what you're actually buying, right, is the battery. It's the battery that costs all the money. Make sure that you get one that's a good fast charge, and also make sure that you always have a spare battery, because then you can have continuous work. If you've got a battery, if you've only got one battery and it runs out, Well, that's it. You know, you've got to wait. You've got to wait. You've got to stop working, and that's always a nuisance. Okay, can't really tell you too much about how to use drills. Obviously, there's lots of little techniques involved. The most important thing you need to know about is the different types of screwdriver bits. Now, there's in the main three. The first one is the old-fashioned slotted screw bit. And these slotted screw bits, they're just a simple, straightforward, bit for an old-fashioned screw. There's nothing particularly complicated. I'll just draw the three in a minute, and it's part of the how do I put it? It's part of the knowledge of a joiner to understand the different screws and the different bits that are available today. So I'm going to just draw the three for you. There's the first one. Straightforward slotted screw. The next one, they're all about the same size pretty well, but the next one, and the third one, okay, so when you look at the three, what you'll see is three different things. The one on this side is a screw, an old-fashioned screw. I remember when I was a lad, people used to supply these screws without a slot, and you had to cut your own slot with a little hacksaw. So that's going back to the times of Noah. Okay, these here are called Phillips. Now Phillips heads are great. They're really, really good. All plasterboard screws pretty well are Phillips heads. They have a simple, straightforward cross in the centre. The cross is designed to be exactly the same size as a Phillips head screwdriver. So the screws and the screwdriver are made for each other. Now these here are Posi-Drive. Now the thing about Posi-Drive is that they're much newer and they are much better still. So these were great. They were a great innovation at one time, but these are even better still, the Posi-Drive. And you know, the P2 or the P1 or the P3, these are the numbers that you need for the different sizes of Posi-Drive. Very, very simple thing, and something that we really need to know about. Now the chucks. The chucks on drills can be all sorts of different types. There's quite a few different types. First of all, there's the key chuck. So a key chuck is a chuck whereby you have a key that fits in it and you wind it. And you wind it, and then you get it tight, and then you turn it around to the next one, wind that one tight, turn it to the next one, wind that one tight, and it's a three-pronged chuck. So it will actually grab hold of the tool like that, and it will hold it very, very secure. The next one is a keyless. Now a keyless is a chuck whereby you hold it in your hand and you just undo it, and it will open, and then you put the bit in, and then you turn it back up and tighten it by hand. These keyless chucks, they tend to be a little bit more expensive, but they do actually hold exceptionally well. And then of course you then got SDS. SDS is a chuck where you pull the top out, pop the bit in and clink it down, and it will automatically hold. SDS chucks tend to be a little bit strong, and they tend to be mainly all of one size, and that's brilliant. And then of course we have the impact driver, which has hexagonal fixings. So this basically is a drill that's designed only for the hexagonal driver, and you literally have a drill and a tiny little bit, you pop your bits in, and then you drill and drill and drill. There's no chuck as such on a hexagonal driver. Okay, drill bits. Now we could spend a month looking at drill bits. There is so many thousands of varieties. We're just going to talk about the most basic ones, the ones that we know about. There is first of all the twist bit. Now the twist bit goes all the way from 1 mil all the way up to 13 mil, or bigger still. And it just basically is a piece of steel, and it's got this curve in it. That curve in the twist bit is designed to remove material fast. So that's why you use them at a really fast speed, and it pulls the material out of the way. If the material doesn't pull out of the way, then eventually that thing will go solid. It will bury itself into the wood. It's used for boring holes in wood or metal, or into plastic. And you could use a wheel brace, or you can use a hand brace, or you can just use a cordless drill. They're all great for all of those purposes. Now the next one is called lip and spur. This looks very similar except that on the end of it, instead of having this triangle shape at the top, you've got two little spurs and a central piece as well. The central spur is designed to keep it in a straight line. The two side wings are designed to cut to sever the fibers of timber as it's going in. So it does actually create a very, very good quality hole. Okay, and you can have them for anything from 1 up to 13 millimeters and beyond. The next thing is the countersink bit. Now a countersink bit is designed to create this V-shaped hole, and every joiner should have 1 or 2 of these in their pocket at any one time. And whenever you need to sink a screw down below a counter, that's what that means, then you can actually pop the little countersink bit, and as you drill it, so it will actually make that little hole for the head to sit below the counter. Masonry bits. Now masonry bits look very similar to a twist bit, except that when you look closely at the end, you don't see a cutter like you'd see on a twist bit. What you're seeing is a masonry bit. You're seeing lumps of tungsten, big lumps of tungsten steel, and what they're going to do is they're going to hammer their way into masonry. That's their purpose. The next one then is the Jennings pattern auger. Wow, I've got 3 or 4 in my workshop. I should probably bring them in to show you sometime, but it's the sort of bit that goes into a brace and bit. They have a square end to them, so they fit into a 4-sided chuck, and they're exceptionally good. I mean, I have a set of probably 15 or 20 of them, and they're all super sharp. So when I'm going to fit doors, I don't even need to take a power tool with me, this brace. And the great thing about the brace and bit is that you don't need to plug it in at night, and it never runs out of power. Then you've got large auger bits, and then you've got the Forstner bit. Now the Forstner bit is a sort of a development from the large auger bit. A large auger bit is a bit that has a central screw, and then it has a cutter that sticks up at the side, like that. So as it's going into the wood, the auger bit will pull itself in. It'll keep screwing itself in. On the outside, the little spur that sticks up, and sometimes there's 2 or 3, sometimes there's 1. But what that does, that scribes the hole, so that it's severing the timber as it's going in, as it's severing the timber, so it's cutting it into a nice, neat, tidy hole. So that's why it's preferred to other forms of cutters. The Forstner bit is just as I say, it's a development of the auger bit, except that it's engineered to a slightly higher standard, and instead of having just 1 or 2 cutters, it might have 4 or 5 or 6. So that's the Forstner bit. The expanding auger. Now this is one that goes in a brace and bit again, but it has that little thing that sticks up, which is on a thread, so it can be unscrewed and it can be adjusted to go further or nearer. And of course you immediately can see that if you extend it, then it makes a bigger hole. So that is an exceptionally useful tool to have in your kit, because what that means is that you can adjust hole sizes without having to get a new auger bit. That's exceptionally helpful. Then we have the flat bit, or the spade bit. This is just a piece of flat steel. It has normally one in the center, and it normally has a couple of blades each side, and as they cut, so they create a relatively clean hole. The thing about the flat spade bit is that there are some newer versions on the market that are much tougher. They have a different profile, they're a bit stronger, and they're actually much preferred to the old-fashioned type. Now you can get what's called a drill and counterbore. This is actually a drill which has another drill down the middle of it. And what you can do is you can adjust the drill that's down the middle of it, and what you can do is you can set it up in such a way that when it drills a hole exactly correct for a screw. It might put in the countersink, it might put in the shank, and it might put in the pilot all at the same time in one drill action. These things are a little bit expensive, but they're worth every penny, and they last for years and years and years if you're careful. 2 more to go. One is the plug cutter. Now the plug cutter is a funny looking device. It really is a funny looking device. It's best used in a pillar drill, and you put your timber in the pillar drill and you turn it around, and as it comes down it cuts down like that, and it cuts in such a way but it leaves the middle bit uncut. And then what you can do, it produces a lot of circular holes but with a bit in the middle which we call the plug. What you can do is put a screwdriver in and just tap it, and a little plug will pop out, and that plug can then be used to fill a hole. It's always made exactly the right size for everything. And what you can do is you can drill a hole and put a plug in with a bit of glue and tap it in and then clean it off, and nobody would be able to tell if there's a screw in there or not. Now that's very clever, and not only clever, but that's actually very beautiful. You can do work in which no screws are able to be seen. And then the last one is the hole saw. So this is I always smile when I think of a hole saw. Don't all these drills make a hole? Well, they do, yes. But this particular one makes big holes. So what this is a large device that has a saw edge all around it. It looks like an ordinary saw. But in the center, it has a drill bit. So what happens is that drill bit goes into the timber, okay? And then what comes up behind it is a saw. And that saw will cut a circular hole, a large one, and then it'll just pop through. Now you can get these little hole saws in all the different sizes. You can get them for design to cut into metal, you get them to design to cut into plastic, you can get them designed to cut into concrete, you can get them designed, of course, to cut into wood. They are exceptionally handy and highly sought after. They're quite expensive. So, my word, we are getting through some stuff, aren't we? So let's just talk a little bit further before we stop. One of the things about fixing is this. It's very easy to just pick up a hammer and bang a nail in, or pick up a screwdriver and put a screw into a wall. What we need to be very careful about is that in that wall there may be electrical, there may be water, there may be your cable lead, there may be your broadband that's below the surface. So if you cut through that wire, the broadband goes down. If you cut through that pipe, the room gets full of water. If you cut through that pipe, you get electric shock. Now, how are you going to avoid that? What are you going to do to know what's inside a wall? I tell you, when I was quite young, I was fitting a kitchen for the first time. I'd made hundreds of kitchens, but never fitted one. The very first hole, right, that I drilled in that wall, I hit a pipe. The customer told me there was no pipes anywhere, but there was a pipe there. I hit it, and there was a very fine spray. It was like a very fine spray, but I tell you what, it soaked the room, and it soaked the room very quickly till we managed to find where we turned the water off. And that cost us a lot of time and a lot of inconvenience. Could that have been avoided? Yeah, it can. It's possible to buy little devices. They're great. They look like a little mobile phone, really, but you just pass it over the wall. It goes beep, 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 and it'll tell you whether it's metal. It'll tell you whether it's electricity. It'll tell you whether it's wood. It'll tell you whether it's brick. It just tells you what's inside that wall. And it picks up the electromagnetism from metals in the main, but you can adjust it for various things. So that's very important to be able to know before you start putting anything on the wall, to know whether there's any cables that you're going to drill into. The second question we've got to ask ourselves is what about the different types of screw? Now I need to do a little drawing again. It won't take a moment. There's lots of different types of screws. I mean, honestly, now there are hundreds of types, but I'm going to draw the three most common. This is the countersink screw. Okay. The second one I'm going to draw is a raised screw. And the third one I'm going to draw is the round-headed screw. Okay. Now they all look slightly different. They're all very similar. They can all be the same sizes. But there's the different type. There's the three different types. So you've got your countersink, which goes below the surface. You've got your raised head, and then you've got your round-headed. Now on the round-headed, it's actually a flat surface underneath the head, so that can go into steel, be great. The second one has it has a countersink, but it also has a slight raised head as well. These are very, very common on furniture, door furniture, very common. They're the most common. And then the last, of course, is ordinary countersunk screws. So these are your three main ones, but I have to say, as I say, that there are many other types, and it's becoming very common now to have screws that are super hard and they have a little scallop out of the tip, which means that as they drill, so they actually create a hole for themselves, so they don't need to be drilled first. Now then, as far as fixings are concerned, we're going to talk about quite a few of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different fixings. We talk about the expanding bolt. Now this is a bolt that goes into a wall, into a large hole in a wall, and then on the outside of it there's a nut for the spanner, and as you turn the spanner, so the thing opens up inside the wall and locks exceptionally tight. That's used to go into masonry. Then we have the coach screw. Now most people aren't aware of what a coach screw is. The coach screw was the first screw that was invented. It looked like a screw at the bottom end, but at the top end it looked like a bolt. So what you do is you drill all the appropriate holes and you push the coach screw in and then use a spanner to turn it. Now I have to say, these coach screws are exceptionally powerful. They're great for big stuff. If you're working on joists and stuff and you want to put a coach screw in, then you'll have a great tool. The next one then is the raised headed screw. We talked about that a moment ago in our little diagram, didn't we? We'd also talked about the countersunk screw. Now they were designed to go below a counter. You know what a counter is? A place where you count money. And if you're counting money and there's nails sticking up, it keeps stopping on the nails. So somebody had this bright idea that will make a nail or a screw that goes below the surface of the counter. That enabled the money to be counted on the counter very well. Then we have the round-headed. Now the round-headed is really designed to be fixing metal down. So it has a flat head to it, but it has a top curved surface. And as it screws in, so the flatness of the surface squeezes down flat. Then we have also the bulge-headed screw. This is an interesting screw. This is a screw specially designed to go into plasterboard. It breaks through the plasterboard in a tiny little spot, but then it doesn't break through the paper at the end of the head. So the paper is drawn into the hole a little bit, and that doesn't break the paper. It's very important when you're putting plasterboard on that you don't break the paper. And then of course we have cavity fixings, and there's so many varieties, I can't tell you. And these are little fittings that go into plasterboard, and as you turn them up, so they expand or they open out or they double fold. There's loads of different varieties of them, and of course go down to the local shop and you'll find. Next one then is the plug and screw fixing. So this is basically a little plug. You drill a hole into the masonry, you put the plug in, okay, and as a screw goes in, it causes the plug to squeeze open out and to become really tight inside the masonry. And then of course we have chemical fixing. The chemical fixing is basically just glue that's pumped into holes, and you put a screw in it and it sets very quickly, and when it sets you have once it's set you have a very secure fixing. Now I'm going to do a little diagram here. There you are, there's two pieces of wood, okay, top piece and bottom piece. You see that? Question you've got to ask is, how do we actually put a screw in correctly? Now you know what, a lot of people don't know this, a lot of people. The way in which a screw goes in correctly is this, is that the first hole that you drill is the countersink. This is going to enable the head to sit below the surface of the timber. The next hole that you drill, it's only in the first piece, is called the clearance hole. Now you say, what's the size of the clearance hole? The size of a clearance hole is just big enough so that the screw fits inside it without touching the sides. It must go through and be just a little bit movable. And then the last hole that we drill is a very fine hole, and it's the size of the inner core of a screw. The inner core, not the outside of the thread, just the inner core. The effect of this is that as the screw goes in, you can see, I'm going to draw it to the side, you've got the shank, which goes through the first part, and then you've then got the inner core of the screw with the thread on it. Okay, so you can see the screw, how it fits in the hole. It's got a countersink, it's got a clearance, and it's got a pilot. Now that pilot isn't the same size as the outer dimension, it's the same size as the inner core. The effect of that is this, is that as you're putting your screw in, okay, what happens is you draw the timber up. Okay, and the effect of that is that the screw effectively bolts the two together. If you're doing it correctly, you don't necessarily need to have a great machine to do it. You literally can use an ordinary screwdriver, and as you turn it, you'll feel the timber coming together. Now, if you don't do a clearance hole on the top piece of wood, then the thread will go up and down on both pieces together, and that will not bring them together. The top piece has got to be the one that has a clearance, and the bottom piece has got to be the one that has the pilot. Okay, I'm glad to see that this is in the book. This is something that is not known for a lot of people, funnily enough. They just shove a screw in and they hope for the best, and that of course is never going to be right. Right, so we're going to catch up with you next time, and we wish you all the best. We trust you'll keep safe in these days, and have a great day. Bye for now.